Hi everyone, welcome to our channel. Today we are going to explore two fundamental ML concepts, bias and variance, and we will see how to achieve the bias variance trade-off. Understanding these concepts are very crucial for building effective models that generalize well to the unseen data. So let's dive in. Let's start with the bias and variance. Like, what is bias? Bias measures the error between our model's prediction and actual value in the dataset. In simple terms, it tells us how much our model predictions differ from reality. Like, we imagine a dartboard and we want to score a perfect bullseye, but having high bias means we are variating from the bullseye to the corner. A high bias indicates that our model is too simple and fails to capture the underlying patterns here. On the flip side, we have variance. Variance here measures the variability of our model predictions for a given data set. It shows how sensitive our model is to changes into training data. A high variance suggests our model is too complex, it is overfitting the training data, very low error on training data but very high errors on testing data. That is, it is capturing noise instead of the underlying patterns in the test data. Now let's talk about the bias variance trade-off. Finding the right balance between the bias and variance is very crucial for building the model. Increasing the bias may reduce variance, but it might lead to the underfitting, that is like high bias, where the model is too simple to capture the patterns. Conversely, if reducing bias may increase the variance. So how do we achieve the bias variance trade-off? Like, we can choose the best model where the error is reduced. Here error can be defined as like bias square plus variance plus irreducible error. We can find the optimal model by choosing the balance, that is to compromise between the bias and variance. As you can see in the figure, the underfitting line just fits straight to the data, while the just right line fits some of the data and assumes the underlying pattern is U here, while the overfitting here takes all the data, all the training data into consideration and try to fit all the data within the line, which is overfitting, and it will result into high test error. So we have to compromise between the bias and variance to achieve less error, and that is what is called the bias and variance trade-off. Generally, these questions are